Hello, everyone. Good afternoon, good evening, good morning, whichever time zone you are. Welcome to the 146th AI Explorer series. We have been doing this for almost 3 years. Just put a one if all of you can hear me clearly. Just put one in the chat if all of you can hear me clearly. So right now we are on Zoom. We are live streaming on LinkedIn, YouTube, and Twitter, where we have hundreds of community members who are joining us. Thank you, Ahmed. Thank you, Divya. Thank you, everyone, for your comments on LinkedIn as well. We are right now. We are going to have an awesome guest speaker, Felix, going to speak. But before that, just want to get a pulse from the community. How many of you are new here to the community? Just put N in the chat if it has been less than a month since you have been to our community events. As I just mentioned, this is our 146th AI Explorer series every Tuesday, 7 p.m. Dubai time. Right now it's Ramadan. That's why we shifted it 2 hours. We do this event. We try to get a guest speaker. We try to talk about topics that are emerging so that every one of us are on ground. So I can see a lot of people putting N in the chat on LinkedIn. So guys, I will just take 1 minute to tell about the ground rules for people who are there. I'm not sure if you are able to just let me just put a see if you guys can see me on LinkedIn. I think there is some streaming issues on LinkedIn. Awesome, no problem. Yeah, there is some lag, so just give me a second. Yeah. So for the people who are new to the community, we will let you know some ground rules that are there. So for the people who are on Zoom, let me quickly. Okay, I think just give me 1 second. The live streaming. Yeah, just anyone can confirm they can see us on LinkedIn. I think in LinkedIn there is some delay that is happening, but anyways, that is fine. We will. I will look into the this thing as well. What is the tech issues that is happening? YouTube and Twitter is working fine. Awesome. So no problem. Sometimes there is a technical glitch in LinkedIn, so we will look at it as well. So awesome. So for the people who are new to the community, let me quickly share my screen so that I will let you know the house rules before we give it to the guest speaker. Cool. So just, yeah. So guys, if you are on Zoom, please switch on your cameras. It's good to see you guys. The mics are going to be off by default right now. Anything that you want to speak, the only way that we know that you guys are listening is through the chat that is there, through the chat option that is there. So please make sure that you are engaging. Just put S in the chat if everyone understands the ground rules that are there. And any questions that you have, we have shared you the Slido link as well on the Zoom, and we are sharing it on the social media platform as well. So you guys can look at it and you can put your questions, and we'll be taking 2 breaks that are there for the streaming rules that are there. And please stay back for the people who want to speak. We are going to have an open mic in the end when we are going to stop the live streaming, and we are going to talk to you guys live if anyone wants to speak. So this is the ground rules for the people who are on LinkedIn, YouTube, and other platforms. Please put your questions on the chat. We will be taking your questions as well in 2 breaks. So we'll have 20-25 minutes talk by Felix, then we'll have a quick short Slido Q&A break, and then we'll continue, and then we'll have the final stuff that is there. Then we will have the Kahoot AI quiz. We'll have the Kahoot AI quiz wherein we have some questions. So please stay attentive. So all the people who are listening to us, please stay attentive. We'll be having a Kahoot quiz where we give some giveaways that are there, and we'll have the winner announcement and the community initiatives that are there. Right. So right now, one big announcement before I give it to Felix, one big announcement. I want everyone to stay back for the Kahoot quiz, and we are going to talk a lot about some of the announcements that are there. We have partnered with JetBrains. Our community has partnered with JetBrains. So we are going to see a lot of initiatives with this specific company as well. As you can see, they have helped us, sponsored us in our hackathons and challenges, and now we are going to see more collaborations in the coming months. So please stay tuned, and we will talk more about this after the next session. So 2 giveaway sessions that are there. First, we are going to do the Kahoot quiz. So in the Kahoot quiz, so stay back till the end. We have two special prizes for the winners. So we'll have this Kahoot quiz. And the second thing is you can scan this. I'll share this guys later to you. You can take a photo of this. Our LinkedIn group and LinkedIn company page is where you need to share about today's session. One takeaway from today's session. It can be any takeaway that you have learned. Please share it on our social media to be eligible to get the prizes as well. So we'll announce the winners today for this. And if you have not won the Kahoot, still you can get the giveaway by sharing one takeaway on our LinkedIn group and LinkedIn company, and the team will select the one which has the most engagement that is there. So stay back till the end of the session. The questions are coming from the Slido itself, so you have to be attentive to this specific thing. So now I'm going to introduce you to our amazing guest speaker, Mr. Felix. He's a co-founder of Xysm and works on the
Zigzum.
development of formally grounded AI system that goes beyond statistical language models. His work focuses on semantic AI architecture based on formal logic, theorem-based reasoning, and epistemological modeling. He will take more about that as well. And instead of treating intelligence as a pattern prediction, Xysm
Zigzum.
develops systems that represents and reasons about the knowledge explicitly, enabling true semantic understanding and explainable reasoning. So over to you, Felix. The stage is all yours. Thanks a lot for doing this.
Thanks, Mohammed, for hosting me. Hello, everybody. Thank you for having me here. My name is Felix. I'm from Germany, and meanwhile founded a company here in Dubai, in the beautiful Dubai, calm and beautiful. Um, Founded in the DIFC, the Dubai International Financial Center, and yeah, so we are developing a novice AI that's doing a paradigm shift. First of all, I see often some people struggling with our name. It's correctly spelled Xixum, and it derives from the tree of knowledge. So this is a Babylonian word for the tree of knowledge. No, sorry, wrong. Tree of life, not tree of knowledge. So this originates some of these ancient these ancient roots, and yeah. So then I would say I would start with the presentation about what is the next paradigm in AI. Well, now we are exploring all the language models and the capabilities, lots of LLM wrappers and agentic AIs. But we all know that these AIs, they struggle with true with the ground truth. So they are good in generating language, but sometimes they can be fundamentally misleading. So it's what we observe is not understanding, but the ability to reproduce patterns of a language at scale. So and in this talk, we talk about how current AI systems simulate intelligence, and why they fundamentally lack understanding, and what new paradigm of cognitive AI could look like. All right. Well, I was long searching for a good analogy how to describe large language models, and finally, I found a good analogy, which is a parrot. A parrot can be trained to rephrase human language, and you will probably rephrase the human language fluently, but at the end, the parrot never knows what he's talking about. So he just rephrases some. For him, it's just noises he has listened to, and then tries to imitate him, but the parrot never knows. what is it about. The same way it is with the large language models. They are well trained on huge amount of data to reproduce the trained knowledge according to the prompt. But yeah, so they're actually quite fluent and seemingly responding, also mimic complex language patterns, but at the end it's just mimicking, and fluency doesn't mean understanding. So these systems, they cannot really understand, they cannot comprehend or conclude what's the content about, and then when their content is contradictory, they cannot say, wait a minute, that makes no sense. So they are merely reproducing what the patterns are providing, and there is no reflection on the output, so to say. Um, yeah, and similar as parrots, large language models behave this similar way. As I already mentioned, trained on massive data sets, optimized for next token prediction and coherent outputs. But in the end, they just generate plausible language, not verified knowledge. And that's the difference where we are currently stuck, that we have maybe plausibility in the output, but it's not a verified knowledge, so to say. So it's not explicit meaning. And why it's not showing? It's odd. Okay,
Are you
no.
trying to share your screen?
Oh, so didn't forgot. Sorry, I was didn't. Okay.
And guys, if you have any questions, please put on the Slido link. I have shared the Slido link. You can put your questions.
Okay,
Yes.
can everybody see the slides?
Yeah.
So
And
yeah, just
this name is like which language? Is it English? Because when anyone when reads this, it is XIXUM.
Zixum.
Yeah. Which is
Zixum.
English language or is it some other
It's
language?
Babylonian. It comes from the Babylonian language.
Zigzom. Okay,
Zixum.
awesome, awesome.
Yeah, so it means tree of knowledge, tree of life. So it's the opposite of a tree of knowledge in the ancient Bible. And yes, and many cultures have this tree of knowledge in their cultural heritage, so to say. Yeah. So I was already phrasing about this. Now I just quickly slide through again. So we are at this stage, but I don't know why this is not showing properly. I'm just doing it this. Um, so the core question is about why large language models hallucinate, and it's because they cannot conclude whether something is true or false because they lack this kind of self-verification, this kind of where they can conclude about the matter itself, but they are more likely reproduce based on these transformer models or how they trained and what's mostly plausible. While they are also backed a little bit in retrieval augmented generation, meanwhile also the chatbots can do execute some Python in the background. That's what they're all doing. So there's also a little bit of a kind of reasoning installed. But if you are using this often, you will find out that sometimes it's plausible, sometimes not, and also it really depends on what you put into the system. How is your how is your context constituted, and therefore it can give you multiple, very different answers on the same topic when you ask them differently. So, yeah, that's why they are more likely target to likelihood, coherences, and statistic fit. But in the end, often you will find out that some. Okay, you hear me?
Yeah, we can hear you. We can hear you. Yeah.
Okay, because it was just a bit confusing when I heard myself again. Um, Yeah, so the hallucination actually occurs because there is no grounding of the knowledge, and it's just produce what sounds right, but not what's valid. So it cannot ask again if something doesn't comprehend and say, "Wait a minute, can you explain it me something again? That doesn't make sense to me." And so the user could sharpen his expression or his prompt, or so to say, until it comprehends. And that's the basic workflow how we are working. We're trying to comprehend and we stopping when there's something doesn't conclude and say, hey, this doesn't make sense to me. Can you please be more precise? Or there are different options, disambiguate, and so on. Yeah, so humans are different, obviously. And we do not reproduce pattern, but we're working on meaning and reason. And this is how human cognition or language evolved. Was not just individually by every human being, but its origin came from cooperation. So cooperation in the humanity required or humans learned by evolving from the apes that cooperation gets bigger results, and therefore we are able to build pyramids or big cities today, and uh, large monuments, or hunt animals in the Stone Age. So humans were able to hunt huge animals like mammoth, which they couldn't hunt before because they didn't know how to cooperate. And this hunting strategy involved a lot of strategic thinking. Also, the cave paintings probably emerged from that. Like today's business meeting with on whiteboards, the same thing was already existing in cave paintings or in cave times. And the crucial difference between primates and humans is that they really tend to cooperate instead of compete. What primates do, primates always take the reward by themselves instead of sharing. But the Max Planck Institute has made a research around 2012 where they found out that children are heavily tending to cooperate and share their rewards among each other. And that gives a good incentive to really cooperate. And that's also the reason why you need a language to really express your strategy to someone else. And this, yeah, works
Alex,
by.
can you do full screen if you don't mind?
Oh, sorry.
Because
Yeah,
people are on LinkedIn, they cannot see because they are on the small screen.
yeah.
Yeah, thank you.
It was because of some display error before. All right. Yeah, it's so language is a direct consequence about it. You negotiate meanings, so people are trying to approach a certain terminology in a certain context, define the concepts, and build a shared mind model, so to say. So they both have the same concept in their head, know how they operate on a formal basis, so they can solve complex tasks in their environment, like hunting in the Stone Age, for instance. So next slide. Yeah, instead of animals are more like learning by behavior, and they are learning by mimicking something, but they never have a true understanding of what they are applying. So they are intelligent like crows. They can be very intelligent in applying tools to solve a problem, but a crow has not a understanding of what's a tool, or so to say. They just learned how to get this to the solution. But humans, oops, but humans, they can comprehend and know how to apply a tool to solve a certain problem. They are they are optimized for problem solving, and this requires another thinking model. So a thinking model that is based on theorems and not on empiricism. But I will come to this later. Yeah. So we defining our environment. We know what a tool is. We understand why it works, and can also transfer this principle to other contexts. This is not that doesn't work within empiric knowledge base. So therefore, we can abstract and transfer the principles to other contexts. Damn it. Sorry, this somehow has a display error. I didn't see that it works. Doesn't work in this. All right, the animal intelligence is behavior-based, while human intelligence is more concept-based, structure-aware, and transferable. Mm. So you can say the core difference is animals learn what works, and humans understand why it works. And so that's the key takeaway, so to say. To make it a bit clearer, let's say we have to solve an engineering problem and building a bridge, and there are two different approaches to solve it. So the one approach is the empiric approach, how current large language are working. They are more intuitively trying to approach this, try different designs, try and error, and then observe, by try and error and reinforcement what works. They are strongly data-driven and pattern-oriented. That's simply how you can reduce current machine learning today. So they are all based on empiric knowledge and not on theory knowledge. But humans work on a theoretical approach. They can define physical laws and model these constraints. It's, so to say, a deductive approach from theorems, and thereby derive valid structures. So it can be validated and proven, so to say. Yeah, and at the end, it's logical grounded, and that's how we are currently doing engineering. That's the core principle behind it. So to summarize the difference, the empirical systems of current AI, they have an approximate behavior. They are trying to mimic the behavior inductively, whereas cognitive systems, they are deriving from theorems deductively into the context. So the others go out of the context and theorems go into the context. So also here, takeaway, the one approximates, the other validates. As I mentioned today, mostly neural networks, regression models, and transformer-based large language models. They learn from a context and try to find out patterns, the patterns that match to the search category, and by comparing different patterns and extracting a similarity there by labeling, you can reinforce a certain pattern. But it also has the danger that patterns are actually everywhere. That's also why when you just do pattern detection without a semantic grounding, then patterns can be actually found everywhere. Maybe an AI will find a face behind in the reflection of this window, and will say this is a face, so to say, because it doesn't look on the context. It just sees the pattern, and then because of amplification of the trained pattern, it just signals, all right, in this reflection here, you can see a window. And that's also the origin of hallucination. Because imagine a person on drugs, he also amplifies certain patterns, and the validation cycles in the brain no longer works properly. And that's why people also start to hallucinate, because the brain is confused with the drugs and no more capable to validate whether this fits into the context, this pattern, or not. And so people seeing ghost faces and whatever. And the same thing happens also to artificial systems when they're not grounded on a context and with a semantic model in the background. Then you will get a lot of false positives because they are not grounded in a consistent context, so to say. Yeah. So that's also the limitation of empirical AI, that they depend on training distributions, and because they cannot conclude, they also cannot define the correctness of their output. And so in order also not the consistency. Yeah. Also, I have to enlarge again, sorry. Right, they work from the behavior, they are seen in a context, but they don't know how the context itself is defined. That's why our approach is different. Instead of we are taking multiple samples from data, we are modeling the meaning. We define the concepts, but it's not like some people are like Palantir are doing. They're modeling huge ontologies, or there's also an older project that's already ongoing 40 years, CYC. I don't know how it's called. So SIG project. They also have a huge ontologies, but the difference to us is that these ontologies, they are human-made, they are constructive, and they have to be very huge because they have to suit to any possible context to be valid. Yeah, and we do not require this because our ontologies, they emerge of the context. So we are stating a certain problem to the context, and then we trying to fit the problem or the concept into the context until it fits. So this also implies concluding of the problem. So like understanding the problem and trying to prove it by a certain version of theorem provers to verify whether this problem applies to the current context or not. And as humans also ask back question, if they cannot conclude something, the system will also ask questions back if based on the given knowledge a conclusion cannot be achieved, and there is lack of specification of the problem to really be that it can be applied in the problem. So as I already stated, context is crucial. So it's all revolves about context because finally context defines meaning. So without a context, you cannot create a semantic meaning because a mathematic principle with freely applied makes no sense because the principle only makes sense when it is applied to a certain context where it aligns to the behavior or what's intended so far in this context. This is also the origin of the still unsolved halting problem, because still today we trying to um, apply mathematical principles like software programs. They are nothing else as mathematical principles. On a context-free problem. So when you have a context-free problem, you cannot know what you want to solve. And if the context is not known clearly, then your mathematical or your algorithms will not work properly and create errors because the context wasn't clarified in so to say. Yes. So at the end, what is for these systems that doesn't lack is the data, but more or less the formal representation inside that data, which means that we do not have a annotation of unstructured data. The machine simply cannot understand which type of data it has it's opposed to and knows how to operate with it. So thereby the user has to come into the loop, so human in the loop, so to say, and must explain the machine by defining the structure manually to really that the problem really is resolvable, because the machine by itself cannot distinguish the semantic content, so to say. And that's still today with current workflows, whether you are modeling N8N workflows, they maybe can automate something with large language models, but they also lack a certain annotation of these models, what they are doing actually. And at the end, you also have an human in the loop who designs all these pipelines, these automation pipelines, and also the machine never can comprehend what is this automation pipelines inside N8N or Zapier or how all these agentic AIs we are meanwhile operating or that's there on the market are really doing. So yes, and the reasoning architecture is different. So we require everything to be in a semantic model that it becomes machine readable, and all the relationships are explicitly represented. So yeah, so the outcomes actually are derived from principles and not statistically predicted. Yeah, so the paradigm shift, so to say, where we are now. So we're coming from the data side, the pattern side, and the prediction side, and we'll be moving to the meaning side, and also not just see patterns, but have the models behind that can really explain how this pattern is embedded in a larger context. And finally, also be able to validate, because we have everything is grounded in a context, that we also can um, constrain everything together and say, okay, we have a pattern detection here in this window. It doesn't make sense because there is no human possible, so to say, in this window. So because only one single pattern that doesn't fit into a larger context is then automatically um, classified as false positive and ignored. And so such system, they can validate itself because they are constraining everything in a common semantic model. Yeah, so our role in this whole thing is that we are developing such a system that is based on formal reasoning. And we're not a generative AI, so to say, but we are trying to conclude the answer based on this the semantic representation of the terms, and also the grounding of the terminology inside a certain context, because terminologies are not fixed. They had to be grounded in the context, and thereby you cannot just define something fix in ahead, like in a computer language where commands they have a certain function, and this is not getting negotiated somehow. But human language is different. Human language tries to negotiate the terms, and so they finally become the true meaning inside the context. One looking on the time.
Yeah, can we have a Slido question and answer break? So I'm getting a lot of questions on the Slido link. And then we can have the second part where you're concluding and showing the demo.
No worries.
Cool?
Yeah, sure. I'll stop my sharing.
Yeah, cool. So guys, just put your questions on the Slido link. We will have an open mic later as well where people want to raise their hands and ask questions that are there. So let me just reload. So Ahmed is asking this question, can intelligence exist without true understanding of meaning?
I would not say, because intelligence is actually you have to embed something. So I would say intelligence only works if you have a cognitive understanding of the problem, and the cognitive understanding of a problem only can derive if you have uh, found out a principle that describes this behavior in a theorem. That's how humans evolved. They on some stage of our human history, they invented the wheel and found out that you can carry loads and don't have to have rolling poles on the ground like the Egyptians had for the building their pyramids. But the wheel follows with the chart, and humans invent such principles and thereby can conclude better about the environment. So we originally come from superstition. So people thought, yeah, well, when there's a thunderstorm, there are gods in the heaven throwing lightning bolts to the earth, and but finally, by evolving through science and deriving certain principles that we can conclude, and then we are getting a better understanding of our world, and also be able to um, achieve more complex problems, so to say. We are today able to build computers because we know how a computer works, and we derive these principles. They were not existing before. So human cognition also works with the evolution of knowledge and the invention of principles that we discover behind certain behavior. So it's not obvious at the beginning that a behavior is given, but by experimenting, we finally figure out how such principles work in nature through physics and other science, and develop a world model.
Awesome,
So
Felix. Cool. Michael here is an old community member. He has been, and he wanted to just ask you one question. So, Michael, I've unmuted you. So, first of all, thanks a lot to join the call after a long time. How are things?
Definitely. Oh, really good. Thank you, Arshad, for allowing me on. Thank you, Felix, for your talk. I really, appreciate the direction you're going. I think Priya is on the call as well. She's definitely more knowledgeable about the language space. I do have one question with regards to, so are you building a layer for LLMs, or are you building a new model architecture? And that is very important, because you spoke to the limitations of LLMs. By definition, like literally by definition,
yeah,
LLMs
we are
are
developing a new
hallucination engines.
architecture, but it
Okay.
also implements other AI infrastructure. We are using the information also from large language models, and um, are grounding these inputs, where we trying to conclude the output, whether it makes sense or not. So it also is part of our business model that we are not just wrapping the client a new infrastructure over the head, but we are more, our business model is more like that we are trying to embed in the current landscape of the client, and just be at the moment an additional layer that grounds and gives um, how to say so we are this is decision we create decision artifacts at the end. So we prove why the content is correct or not. So we at the moment designed as a control plane, but our future goal is to be also a data plane where you can really do engineering works and so on. But this will be a longer path into the future. At the moment, we just reduced our solution on a control plane, but that's not where we want to reside. But this is something what's already achievable with the current technology. But as yeah, this whole thing progresses, our aim is to be a full spectrum data plane where you can do all your engineering works or whatever problem solving you want to do. But it is still future music. At the moment, we're trying to go for low-hanging fruits, and low-hanging fruits are, let's say, enterprise resource management problems that we are comparing, for instance, whether bills are correct and all the constraints in your
Right.
business process conclude, make sense, and also are compliant to certain policies. And that's our current use case,
Okay.
so to say.
Not a problem. So I would say, be kind of careful with, throwing around terms like truth versus fact, because those are not the same thing, right?
Sorry?
So I said, so you spoke to truth, and I would say I think you're leaning more towards fact based, right? Because truth and fact are not the same thing. A truth for you is not a truth for me, but a
Yeah,
fact
yeah.
for both of us, right? So that, but I honestly like to defer to Priya, because she's has significantly more research and development and pioneering efforts in this space. So thank you, Arshad, for the chime in, and thank you, Felix, for the answer. So I'll
And,
defer to Priya.
You're
and
welcome.
Felix, are you still in office? I can see this is looking like Dubai AI campus office.
That's correct.
Ah, so late. Cool, cool. I'm unmuting
It's
Priya.
still standing.
Yeah, cool. I'm unmuting Priya. So Priya is developing something in this space as well. So Priya, you wanted to ask something or give a comment?
Yes, thank you. Thank you, Arshad. Hi, Felix. We are also up at DIFC AI campus, so we are fellow founders. And I'm glad to see that somebody is working on the kind of thesis that we have been working on as well. Now, this is a lonely space, but no, I'm glad that you are there as well. So everything that you said initially, I agree, because language, we believe, is the foundation of intelligence. That's how we connect with everything around us. That's generational knowledge is developed and preserved across various communities. My question was around cognition, right? So you're talking about developing a cognitive machine. Isn't cognition very much related to, let's say, various reasoning types, reasoning patterns? And we all know that currently LLMs, because they're trained in large English data sets, it's very Western-centric reasoning patterns. Um, so how do you not take into consideration, how do you make sure that the reasoning patterns of various communities, linguistically diverse communities, are you know uh, checked or represented? How do you validate that across multiple cognitive, diverse cognitive or reasoning types?
Yeah, coming from the current large language domain, well, it's a bit misleading today. Well, there are many influences in the internet. They say, yeah, we reach AGI, and DeepSeek introduced the term reasoning, but that's honestly, it's a bit term hijacking and misleading, because these large language models, they are not based on grounded reasoning, so to say. They don't try to conclude something. They are iteratively piping the output in the input and iteratively improve the output, so to say. And real reasoning and cognition, honestly, in my opinion, comes from the derivation of principles into a context, and verify those principles in this context, whether it makes sense or not. And as we also know, in human communication, there's a lot of space of misunderstanding, but this only happens because we still didn't synchronize the semantics of certain terminologies together, and have the same understanding of the terminology. And this often requires an adjustment when people are coming from different backgrounds, and this also applies to systems, that each systems coming from different backgrounds first need to find common ground in the terminology to really communicate on the matter, on the same matter. So, and at the end, cognition is something that's be verified by the given context, and whether it makes sense in the given context or not. And when it does make sense, then the system has to ask further questions. Say, I cannot conclude because this lack of information. Or let's say you say the president of the United States, and then the system says, yeah, well, there are many of them. Which one do you mean? So we have, let's say, an underspecified problem, and then the system requires more information from you to really conclude what to solve. Also, the same goes for disambiguation. Also, when there are contradiction in this, so if you're telling the system a lie and it tries to solve the problem, and it's based on a lie, it says, yeah, well, obviously that doesn't make sense. And so we have actually something that is also a debunking of lies at the end, now, because the system only can resolve something that can also be concluded, and be made all the constraints can be satisfied. And if something makes no sense, then the problem cannot be satisfied.
Awesome. Priya, you have any follow-up questions? I think we will let Felix conclude the demo. And then maybe
Yeah.
if we have any more questions, we will be taking it after the session. So guys who are there waiting, we have hundreds of you joining us across LinkedIn, YouTube, and Twitter. So please stay back. Just give me 1 second, Felix. Just let me tell them. So please stay back. We are going to have the second segment after this, where we try to answer some of your questions. We are going to have an exciting Kahoot AI quiz on this topic, and we'll give a winner giveaway as well of some of our scholarships of our program. So please stay back. And then in the end, we will have open mic where we can hear from some of you that is there. So over to you, Felix. You can just continue sharing and doing the demo, and then we can.
Of course. Where's my share? Here, okay. Sharing desktop. No? Okay. Okay, so should be called backend. This is a typo. So yeah, so that's well, it's some of our ontologies, so to say, and also it's not handled as text, but there's a comprehensive knowledge graphs and ontologies that are the fundament of our reasoning. So that they just build the fundament, they map the knowledge, and then you trying to satisfy this in a given problem context, or in a context, the problem into the context. Yeah, so at the end you get a kind of a reasoning trace. You get an answer how this solution come together based on which input information, and thereby trace back and ground it why this is valid or not valid based on the input information, so to say. Next slide. Yeah. So yeah, our vision, the next generation of AI, obviously will not be by better large language models, because they just maybe put more steroids on the same principle. They may, and also it's like with all machine learning problems, if you over pitch it, then you are getting a more paranoid system at the end. That's also what's often discovered, that the bigger the model is, it often also can it also produces a more paranoid system. Yeah, because at the end you're not grasping the true problem of cognition at the end, but you're just trying to mimic it to a certain degree without understanding. So when you have no clue about what's is about, it's like we falling back to the parrot, who is fluently trained on reproducing human language, but he never can reach the formal principles that are hidden inside these language patterns. So how they come together, it's not available to the parrot's mind what these language patterns really mean. And only if you have an understanding of the meaning, then you finally can also operate on top of it. Otherwise, you just become a huge plausibility machine, and yeah, so you never will reach true knowledge. You're just mimicking intelligence at the end. It's not real intelligence, so to say. And yeah, so closing words will be machines that we're moving from machines that speak to machines that reason, and from systems that initiate intelligence, imitate what I already said, imitating intelligence like the parrot, to systems that understand and also validate it. And validation is crucial to really have how to say, to really know whether you are doing the right thing. So validation in informatics always ask, do I modeling the right system? And this is all about, at the end, to understand whether I'm resolving the right problem or I'm doing resolving something else. Okay, then we have developed a certain user interface look and feel prototype. It's yet the back end of the reasoning engine is not yet plugged in. So you're just seeing a front end demo how such a system could look like in the future. And these are just first concepts. But yeah, so this also has evolved a little bit, but just giving you an impression about how such a system could look like at the end. So, oops. No. Sorry.
Someone hacked into your system.
No, I was just having to try. I hope this now works. All right. Okay, it's so this is our dashboard, so to say. Let's say we have a history of tasks we have done or new tasks, so we can refer to old tasks or create new ones, and also define the roles we are currently in, whether we are more a creator, an auditor, or an explorer. This is something it's still some experimental things we are playing around. Then also we can plug into to already the environment of the existing environment of the client. So when he's already having an AI stack in his company, then we are attaching to this and implementing the infrastructure, which also involves that we can plug in his models, that we can then conclude whether these outputs are correct, but we're not depending on it. So we actually, because we are a reasoning platform, we also derive the solution on ourselves. But sometimes when the problem is a bit fuzzy or more heuristic, sometimes some problems are better to first approach in a statistical way before you really do some reasoning on top of that. So that's why we are not exclusively relying on our own approach, but we also implement the more empiristic domain of large language models, especially when the problem is cannot be sharply framed, so to say. And but in the core, we develop our own engine that also can work without large language models. It's more or less that we are trying to adopt into a client's environment. So I prepared some demo. So like, sorry, I need to move this. let's say you are a commodity trading company which is in the oil business, and you want to do some due diligence, whether your contractors, they are trustworthy or they are pulling you over the table with fake data and just mimicking a trustworthy client and pretending they maybe are in hold of a certain commodity they want to sell to you. So you have to do your due diligence. Usually you involve many operators. They're doing manual due diligence based on the given information, let's say emails or locations where certain oil storages are located, and thereby verify whether this information the contractor gives is trustworthy and you're safe to buy from this contractor, or he's just fooling and tries to pull you over the table. So we are just here. It's mimicking a conversation with the system and try to approach the problem. And as you can see, we have different complexity hierarchies where this is the root layer. And then we go also inside those modules to define the problem in a more fine granular detail. And so we could have multiple complexity layers that finally operate with each other on a certain abstraction level, because also language is something that can be highly abstracted and also be very precise in details. So you have also shifting abstraction layers in natural language. And the same also goes for the system, that you describe the problem on different abstract layers and abstraction layers and resolve conflicts in the granularity level where conflicts are occurring. And so we already found out there are some contradiction here in the given data, and the system already reports that this data has contradiction and then transfers it further to the outputs. And then also original inputs become disqualified. And so we know that the system cannot trust it further. So then we do certain assessments, like let's say, for instance, locate the facility, or whether, so like what the client has given and the real GPS coordinates, and if there is a mismatch, then we find, okay, the client obviously gave us wrong information about the location of the commodities, and thereby we figure out that this is something fraudulent. And so we are navigating through the different hierarchies, yeah. So to say, let's say we'll see whether the ship was like it's an oil tanker, whether the coordinates of this oil tanker are correct. We are maybe attached to these ship tracking systems, where we can then see whether the ship is also at the location, and also the draught maybe, well, they say this is a full ship that's full loaded with oil, but when the ship is fully loaded, the draught must be different based on the data of the ship. And so we also can figure out whether this data makes sense, or it's obviously not loaded with the pretended data, with the pretended commodities, because the data of the ship doesn't make sense according to the pretended load, so to say. yeah, and so we also derive some warnings and say, okay, this is something that's suspicious, and then we move out again from the storage verification into the parent scope and do more verification in another module where we also assess maybe certain GPS data and thereby figuring out whether this there's some odds in the data that makes the whole thing suspicious and require further assessment. Yeah, also KYC of the bank where the contractor is transferring the money, so we can also trace back whether this money is a trustworthy bank or it's maybe a gray listed or blacklisted bank. So because when we are transferring the money from a blacklisted bank, where then we also become compromised with money that comes from the black market or from the dark market, and so we can also do some kind of a KYC assessments, and finally all the data is collected and goes into a final risk engine, and where all the data is collected and the final report is made, whether this whole client is trustworthy or not. And yeah, so you receive a report whether you can trust this client or not, and then receive this kind of a decision artifact, knowing whether you can pursue business with this client or you better take your fingers off it, and so on. Yeah. So yeah, that's it. And then you can navigate through the whole hierarchy, so to say. Yeah.
Awesome. So your demo is done, right? So yeah. So anything else you want to? So first of all, thanks a lot, Felix, for your presentation. We have a lot of questions that are coming in on the chat as well on the Slido. But can we first do the Kahoot quiz? Because a lot of people are waiting for the Kahoot quiz, and then we can take few questions that are there. Cool, Felix? Cool.
Yeah.
So, okay. So guys, we promised you that we'll be doing a Kahoot quiz. So I request all of you we'll have quick 5 questions Kahoot quiz from today's session, and then we will take some Q&As that are there. So please make sure you are running this. So this MCQ is designed by Felix itself from this call. So please try to let me also share this on the social media platforms as well. First, so guys, the 2 winners will be getting scholarships for our 2 courses that are there, evaluations for AI and Python. So please scan it, and we'll request some more participation so it's more fun. You can also share it on the different platforms. And also on the chat. Yeah, I have shared the link here in the chat as well, and then you can also scan the QR code. And also, guys, if you guys have any open questions, please put it on Slido. If we are not able to answer it today, we will reach out to the Slido itself, comment option, where we put the answer. We will start when we have at least 15 people. We have around 25 people on Zoom and 100 people on social media, on LinkedIn, YouTube, and Twitter. So we at least expect 15 plus people. We have someone with your name. We will start in 20 seconds. So please, guys who are taking time, just go to kahoot.it and type in 135 1856. Cool, I think. Cool. We'll start.
Time's up.
Congratulations to the top three winners. So we have first one, we have Sumaya. Awesome, Sumaya and Divs. We have, let me take a screenshot of this. Just yes, I hope someone took the screenshot of the fourth and fifth. Awesome. So guys, just put a K in the chat if you guys enjoyed the Kahoot quiz. Awesome. So one of the best parts of our online events are when we asked few people, they really enjoy the Kahoot quiz. So thank you each and every one of you on participating in the Kahoot quiz. So Sumaya and Divs, congratulations as well for winning it. And all of you guys are winners. It's just that we want to celebrate only the this particular thing with by giving giveaways of our scholarship to the top two people and taking it further. So now we will try to take few questions from this and just stay tuned, guys. I will just tell as well. So Felix, just we are getting some questions as well on Slido and this thing. If you want to explain to an 8-year-old person what problem you are solving, if you what problem is your company trying to solve? If you want to explain to an 8-year-old person who's not that technical, how will you do that? Or to a business person, like you showed petroleum company, right? Who does not understand anything. What is LLM? What is this? How will you explain him? Can you just tell that because we are getting few questions on that.
Yeah, we're not just predict the plausibility of the problem, but we are really trying to conclude and understand the problem and thereby uh, derive the solution out of that. So it's really a logic conclusion or a logic solution. Yeah, solving instead of a probabilistic guessing. So you may, like the probability to a certain degree you are right, but you never know whether you're right based on which foundation. So it's all black box, so to say, and here you have a really proof why it's correct or not.
Awesome, awesome. And okay, we will try to take one few more questions from LinkedIn as well. So, Ahmed is asking one question about what is the biggest limitation of current LLMs in this high stake use cases?
Well, they cannot grasp the problem, so they will always tend to hallucinate because um, they never can conclude or comprehend, like they never can verify if their answer is correct or not. So there's no verification of the answer possible. No matter how good you create the models behind, they can never verify itself. Yeah, the answer cannot be verified.
Okay. And which one last question we will take for today is from Sumaya, is which real world tasks need cognitive AI rather than LLMs?
Well, especially when it comes to engineering solutions, like where you really have to understand the concept behind. And it's also to a certain degree a matter in vibe coding. That's also, well, we are getting good results out of the current coding agents. But at the end, it's still pattern matching and try and error, so to say. And often, what comes out is more or less something that lacks a certain architecture, whereas it becomes more hard to maintain spaghetti code. So the code often comes out has a certain spaghetti nature. While the system getting better, but there's often when I am also doing these kind of using these coding agents, I very often figure out that they don't understand the problem itself. They're just trying to somehow match. It's like this kind of. I have it also in my presentation. This in the slide. Let me just go back to share my screen. Right. Here, by the way, it's my email address for if somebody wants to get in touch.
And
Also,
I also
LinkedIn.
shared your LinkedIn on the chat as
Yeah,
well.
okay. Yeah,
Some
then
of them were asking your LinkedIn. I've shared it on the chat as well, so you guys can connect, follow
these
as
kind
well.
of toy boxes where you're trying to put something in the right in the right hole, the shape, and that's also how these large language models are operating. So they just trying to force something inside or these coding agents, and sometimes it works, sometimes not, but they never know why. So they don't know, oh, this has this shape, has to go in that shape. There's a funny video from a lady who there's a meme, a video meme. I didn't made it because lack of time to show this funny video, but it's it's a very funny video of a woman who just rewards someone who puts these kind of toys into the right hole, and then finally, yeah, it's just a good analogy how these systems work. It's just trying to force it through, and it often doesn't fit because they don't understand what's the real principle behind it, and that's the main problem with current coding agents, so to say. And yeah, so they may for general problems they may be a good tool, but when it comes to more engineered solution, then they have their limits for sure. And that's where these cognitive machines in the future will shine, because they can go through this barrier, because they really can conclude the problem from a theoretical base, and yeah, which is not able for the large language models.
Cool. So, with Felix, yeah, just let me quickly, there are some questions on LinkedIn as well, but I have shared your LinkedIn. I just want to tell people we have 4 more minutes. I will just share people. Some of them are asking about the giveaway. So, guys, for the giveaway, I will share this as well. You need to, the people who have won, you have to share about LinkedIn, take a screenshot. We have put the screenshot of the winners on our WhatsApp group. Share it on LinkedIn, tag us, and the team will reach out with you with a coupon code for the giveaway. And the people who have not won the Kahoot quiz, I will just share this also on the chat, our LinkedIn company page as well. So please make sure you tag us here so that we know that you have posted, and we will be giving you guys the giveaway. But for the people who could not win, you are still eligible. You can still share a takeaway of today's session, tag DDS on and put it on the group as well, and we will be able to give you guys the most engaged one, the takeaway. And one more announcement that I told all of you is, look around. We have done a partnership with JetBrains. One of the JetBrains ID is number 2 in the world, so it is very much used. And we have going to have a lot of collaborations. You can see they helped us in our hackathons that are there, and also in the coming events that we are going to have with them. So please stay tuned for more updates, and also for the volunteers that are there, people who are actively contributing. So we are going to have a challenge for them, and accordingly we are going to give one license worth $100,000 to that person accordingly. So this is awesome as well. So now that this is the two things I wanted to share. And Felix, any concluding thoughts before we wind up the call for today? I know there were a lot of questions. This is something different that we are trying to solve. And best of luck for whatever you're doing, and you get more success in your projects and people understand. I think the what you're trying to solve, it requires people to have some knowledge and some technical know-how of these things so they can relate more to it.
Is this the conclusion, or what you're
Yeah, the
sorry.
conclusion before we wind up for the call for the day.
So yeah, well, you don't have you don't have to have the knowledge in head. You just state what the problem is, and then the system tries to conclude whether it can resolve it. And so it works out the problem with you. So you don't have to provide certain knowledge, because based on the problem statement and the available solution, because the system over time learns also certain solution, how to approach a certain problem. Then it can resolve it mostly by itself with some feedback. Let's say you say make me a car that can fly. So then it tries to assess whatever it makes sense, and finally comes out with a solution. Well, what is achievable with the current state of knowledge and what's not. And when it can find a conclusion, then it will return with the solution and say, okay, this is how a flying car could look like, for instance. And I validated according to certain constraints, what are the basic requirements, and let's say weight, load, speed, fuel tank capacity, then the range, and so on. And you give all these parameters in, and then it tries to satisfy the problem inside this given problem domain.
Awesome. Thanks a lot, Felix. Yeah, thanks a lot. And look, thank you each and every one of you to stay back for 90 minutes. And we have hundreds of people on LinkedIn, and there are a lot of questions on the comments as well. So this is a developing solution, and you will keep coming to our community meetups. We try to get guest speakers who are trying to solve some problems that are happening right now in the space of technology and AI. And thank you each and every one of you to stay back and keep yourself motivated till the end. And looking forward for all of you to join our next session. So Eid Mubarak to everyone who's celebrating Eid. So Eid is maybe going to happen on Thursday or Friday and Saturday. And before we conclude, guys, we have a very important, right? End of the day, as Felix and everyone talks about it, data is the most important thing, right? How you are structuring, especially for enterprises. The people who are using AI, data is the most important thing, and that's the reason why we do a lot of data science and data engineering workshops as well. So this Saturday, I request each and every you who is a little bit serious in making a career and understanding this space, join this session. Where we have one of our community members from Google Developer Expert going to talk about designing data platforms for AI agents and not just dashboards. So this is an awesome session that is going to happen on Saturday, 11 a.m. So please register for this as well. We are going to have a Kahoot quiz in this as well. So keep the momentum and keep the energy high. So thank you each and every one of you to join the session and have a